The tool that we're going to be using to replace and mock and be able to simulate users and simulate services that provide data remotely. We're going to be using Jest. Jest is one of many testing environments that work well for with Angular, with React, with quite a few of the JavaScript frameworks. This is just one of the frameworks. There's tons of them out there. They all try to accomplish similar things, right? We already saw some of the concepts, right, that they all fall under, right? They need to be able to take the place of an actual user. They need to they need to be able to provide isolation from servers, being able to isolate the code so that it can be exercised all by itself, independently of any other dependencies out there. So the concepts are the same across all these frameworks. The difference is that they all have different syntax. They all have different things that are easier to do than others. Some of these tools need to have additional libraries to be installed. Just is a good first start at a framework that provides more or less pretty much anything that you need. Certainly, you can improve by including several other libraries that are out there along with Jest, right? But we're going to look at the bare bones implementation of Jest, right? So it's a Node.js tool. You should already have Node.js installed since you're already using React. And to install it, you use npm install and Jest. This will download the library and will add it as a dependency to your project. Okay. Later on, this will be important. When we come back next week, when we come back from the break, that we'll be able to automate these tests, right? So make it part of the build process when we integrate it with a continuous integration tool such as Jenkins. Another tool that you'll need to install globally, right? It's a command line tool, also called Jest. This will allow you to run Jest from the command line, right? So it's a command line interface that you can run the test from your command line. Eventually, when we come back and do some continuous integration, we'll have Jenkins do all this automated stuff, right? Right now, we're going to do it all manually, but we'll automate it when we come back after the break. After you have that, let's take a look at a really trivial example of just giving you a flavor on what testing would look like. So here's a really simple, trivial sum implementation algorithm that just adds together A plus B. Right? And we like to see if this works as expected. So this is a self-contained module. This is using Node.js's module implementation. Right? It's exporting the sum function so that it can be imported from other pieces of code. So it's not using ES6, right? But this is a pretty standard mechanism for modules to be able to reuse modules in Node.js. And so here's another file. Notice the naming convention. The file here is called sum.js, and there is a sister, a mirror image of this file that is related to that other file. Notice it has the same naming convention. It has sum, but it has .test to the name. Okay, so this tells Jest that these files are somewhat related to one another. Okay, here we are loading that module. This is what we would refer to as the module under test. We are testing this module, right, all by itself, and see if it behaves, if the implementation works as expected, right? And we would like to verify that something as trivial that if 1 + 2 is equal to 3, right? Something trivial. What Jest gives us is an API that allows us to define tests, right? And the API is based on the following functions that Jest declares. One of them is a function called test. Okay, that's the name. That's the name of the function. And the function takes 2 arguments. Right? The first argument is a name that you can give your test. Very much like in Java, you can use annotations, right? And you can name your tests so that when you run them, if they fail, you know which one failed, right? So same thing here. So here, typically that description would be the expected behavior of this test, right? I want to make sure that if I add 1 plus 2, that's equal to 3. Okay? So that's what test does. That's the first one. The second argument is a function that will execute when you run the tests. When you run your test suite, it will run through all the tests and will execute each single function inside of each one of the tests. In this case, our curly bracket defines this test here, and the only thing that it's doing here is just using the expect function. That is also part of the Jest API, right? The Jest API defines an expect function. That what it does is that it can take as argument an invocation of a function and then verify or compare the resulting value from having called that function and compare it against values that are numerical, strings, or compare arrays, compare objects, compare all sorts of things. The most trivial one is called a to-be. And so what the expect function returns is a meta object that can be compared, right? That has an API that allows you to compare all sorts of things. Where the output here was numerical or a string or an array or an object, right? We can compare it with the expected value. In this particular case, the value that comes back is an integer. So sum 1 plus 2 returns an integer. And so the meta object says, okay, we'll retrieve that object and compare it to 3. And so this is like an assert. Right? This is like the equivalent of an assert in JUnit. Right? This is asserting that this is true. If it is true, then everything's dandy and everything passes. So you can run the tests by using npm run test. And what it'll do is it'll find all the files that end with .test.js, right? And we'll execute them. It found one, sum.test. It runs them. It prints out the text for that name of the function that we just, or the test that we ran, and it gives us all sorts of sort of statistics, right? Typically, we'll not just have one assert. We'll have lots of asserts, right? And we'll have lots of tests, and this will print out, right, a statistical analysis of what passed, what failed, and whatnot, right? If it passes, it prints it in green, and that particular test passed. It types in every single test that ran and some statistics of which one passed, which ones failed. Okay, so the tests compare actual values with their expected outputs. Right. Now, to see a false positive, we can cause a deliberate failure, right, and check to see that we would expect that 1 plus 2 is actually 4, right? Obviously not. But let's just for the sake of argument, let's change it so that to see how the test fails, right? So when we do that and we run the test again, npm run test, it prints out the names of statistically which one of the tests failed, which one passed. In this particular case, it's telling me that particular test failed, and it points out exactly what line of code was the problem. Where's the offending piece of code, and points it out, saying this particular failed. Right? It also prints out that I was expecting 4, but I actually got a 3. I was expecting that 1 plus 2 was 4, but actually I got the correct answer that 1 plus 2 is indeed 3. Right? Make sense? Now again, these are all going to be manual for now, right? Again, when we come back, we'll put all this part of the continuous integration, and have all these tests run automatically. The intent is that whenever you make a modification, whenever you make a piece of code, and before you even submit this as a pull request, or even before committing, right, you would run all your tests locally, right? Or you would have an auto watch that looks at any changes of the source code and it runs your automated test immediately, right? So that every piece of line of code, every single keystroke almost, you want to catch to see if you just broke something, right? With that, and ideally you would create all these tests a priori, right? This is the mantra of the test-driven design, right? Where you write tons of tests at the beginning. Usually those tests derive from the specification, a formal implementation of the specification, and then coding then becomes an exercise at passing your tests, right? And you know exactly whether how far you are into completing your task, right? There's an objective measure of how much are you done, right? It's you're done when all the tests pass, right? And that there's an objective measure of how much you're done. There's no, oh, I'm almost done, right? I'm 30% done. I'm 80% done. I'm 90%, and then you're stuck there forever. All right, so let's talk about snapshot testing.